Drones are here to stay. They're not going anywhere. In the near future, we will be seeing a lot more drones simply flying for diverse reasons. And we need technology that can control and detect them, be it for package delivery, for security, public security. It could be, like you said, a patrol drone that's inspecting a park, or use of drones for bad reasons, for drug smuggling, for carrying explosives or radioactive material. And of course, espionage. Espionage not necessarily just via video and photo, but also with Wi-Fi interceptors. Drones can actually get the signal of a Wi-Fi router and phish documents or other sensitive data within your organization. I'm Lee Jones. I'm the Regional Sales Manager for the Americas for Dedrone. Dedrone is a drone detection technology company. We're a German startup, now based in San Francisco. And we developed the DroneTracker, which is key infrastructure for security and detection of drones. We have correctional facilities, we have border control, data centers, stadiums and arenas. We also have public spaces like parks or events in public spaces, amphitheaters, etc., that require technology that tracks and detects drone activity in the lower airspace. The DroneTracker is a sensor packet comprised of a video sensor, 2 microphone or acoustic sensors for basically all acoustic and ultrasonic. We have an infrared sensor. There's also a wireless receiver or wireless sensor on this other arm. Dedrone developed something we call drone DNA. So it's the very particular things that are inherent to drones in terms of the acoustic ranges that the motors will emit sound in, the different radio frequencies that they intercommunicate with the RCs, and also the actual shape and form. So it will basically identify, by comparing within our libraries, the different visual aspects of the drone. A lot of video analytics takes place there. At the end, everything is weighed in within our algorithm to deliver an alert, and a positive alert. The objective is to distinguish definitely from a drone and anything else that is not a drone. We will compare it in the background to other types of imagery like actual commercial planes or birds. It will cancel them out and leave us only with the image. Once the alarm is triggered and we have an actual alert of a drone, we will deliver an automated message via SMS, email, or even an acoustic or light alert within a center of security operations. Every alert, any positive alert of a drone will immediately flash the contour of the box in red. So we will not only get the textual alert that there is an alarm, but we will get the red flashing. We can also put acoustics into that and we will get an alarm actually sounding. And the red dots are definitely on the wireless or the Wi-Fi sensor when we identify a MAC address or an SSID that's correspondent to a drone. So it will make the difference between a mobile phone, a smartphone, a wireless router, an actual drone from any company that develops drones that use Wi-Fi. We will frame them in green when they're not a drone, like birds, like foliage moving in the background or a flag, and anything that's positively identified as a drone will be framed in red. We can identify good drones basically by feeding them into the library and labeling them on whichever aspect we would define as good drones or friendly drones. Label them as a police drone or a fireman drone or a media drone in different types of events and cases where they will be flying. The user interface basically will give us an inventory of all the sensors that are active. In this case, we will have 2 or 3 sensors that are being visualized at the same time, and we have different windows for each one of them. So we will get the live video feed on one window, and on the next we will see the different acoustic levels that are being sensed or recorded at the time. Everything is automatic, from the sensing to the alert, and even automated recordings of the events for forensic applications, for forensic uses, is done automatically.